All right, Parkinson's disease part 4. This is where things get a little bit more complicated because I'm going to go over the direct and indirect pathways of the basal ganglia and those functions. And so just hang in there with me. If you guys have any questions about any of these processes, please leave me a comment or direct message me because I'd love to go into detail with you about any confusing or muddy points. So within the direct and indirect pathways, each portion of the brain in the pathways is either going to produce GABA, which is inhibitory, glutamate, which is excitatory, and then you have the substantia nigra, which produces dopamine, which, depending on which pathway it is functioning in, can be either inhibitory or excitatory. So we'll go over the direct pathway first. In the absence of modulation from the basal ganglia, which is this whole section here, the thalamus exerts an excitatory influence on the motor cortex and increases movement. Alright, so at rest, the globus pallidus internus inhibits the excitatory signals from the thalamus by releasing GABA. So GABA inhibits the excitatory signals being sent to the motor cortex from the thalamus. So in order to initiate movement, the motor cortex sends an excitatory signal to the striatum. Thus, the striatum increases the neurotransmitter release of GABA to the globus pallidus internus, which then inhibits the globus pallidus internus. So the inhibition of the globus pallidus internus release of GABA leads to what we call disinhibition of the thalamus and results in increased motor activity, because when this inhibits the thalamus less, we get greater excitatory signals sent to the motor cortex. So this is where dopamine comes in. So the subthalamic nucleus sends excitatory signals to the substantia nigra. Then the substantia nigra sends dopamine to the striatum. In the direct pathway, dopamine acts as an excitatory transmitter by binding to the D1 receptors in the striatum. So the excitation of the striatum leads to greater production of GABA to further inhibit the globus pallidus internus. So you get even more disinhibition of the globus pallidus internus. So then the thalamus is able to excite the motor cortex even more, and you get greater movement. So, in the direct pathway, the production of dopamine leads to greater amounts of voluntary movement.